Hello everyone. Welcome to today's lecture on large span structures and launching techniques for heavy decks. Large span structures are an important part of modern civil engineering because they provide wide open spaces without intermediate columns. They are commonly used in airports, stadiums, factories, warehouses, railway stations, exhibition halls, and shopping complexes. These structures improve functionality and allow better movement of people, vehicles, and equipment. In this lecture, we will also study how heavy bridge decks are launched using different construction techniques. By the end of this session, you will understand the structural forms, launching methods, advantages, and practical applications of these engineering systems. A large span structure is generally defined as a structure with a span greater than 12 meters. The main objective of these structures is to create large uninterrupted spaces without internal columns. This provides greater flexibility in planning and allows better movement of people, vehicles, machinery, and stored materials. Large span structures also improve visibility and reduce the number of foundations, which can lower construction costs. They are widely used in factories, warehouses, aircraft hangars, shopping malls, sports stadiums, gymnasiums, exhibition halls, and public auditoriums. Their ability to cover large areas efficiently makes them an important solution in modern construction projects. Several structural systems are available for constructing large span buildings, and engineers select the most suitable one based on project requirements. Common systems include post-tension concrete, pre-tensioned concrete, fabricated structural steel assembled on site, prefabricated steel structures, in-situ reinforced concrete portal frames, precast portal frames, and prefabricated steel portal frames. Each system has its own advantages regarding strength, construction speed, economy, and maintenance. The final selection depends on factors such as span length, loading conditions, construction time, equipment availability, material cost, and the intended use of the building. Proper selection ensures safety, durability, and efficient structural performance. Heavy bridge decks cannot always be constructed using the same method because every bridge project has different site conditions, span lengths, and construction requirements. Engineers therefore select the most suitable launching technique after carefully studying these factors. Reinforced cement concrete bridges may be built using either cast in-situ construction or precast segmental construction. The common launching techniques include the balanced cantilever method, span-by-span method, progressive placement method, incremental launching method, and the movable scaffolding system. Each technique has specific advantages, limitations, and applications. Selecting the correct method helps improve construction speed, safety, quality, and overall project economy. The balanced cantilever method is a widely used bridge construction technique where construction begins at the pier and progresses equally on both sides. Segments of equal length are added one after another so that the bridge remains balanced throughout construction. This balanced arrangement prevents excessive bending moments and improves structural stability. Temporary towers, support frames, or counterweights may be provided whenever additional support is required. This method is generally suitable for spans between 6 and 12 meters, especially where ground-based supports are difficult to install because of rivers, valleys, or busy roads. However, constructing the pier table requires careful planning and considerable time. The construction of a balanced cantilever bridge follows a systematic sequence to ensure safety and stability. First, the pier head, also called the pier table, is accurately constructed because it supports the entire cantilever system. Next, a steel gantry is fabricated and installed to carry construction equipment and materials. Formwork for the soffit, web, and deck slab is fixed on both cantilever arms. Reinforcement bars are then placed equally on both sides to maintain structural balance. Finally, concrete is poured and allowed to achieve the required strength before constructing the next segment. This sequence ensures safe and efficient bridge construction. This image illustrates the balanced cantilever method in action, showing the construction progress of tall structures from the pier outwards. The span-by-span method is commonly used for constructing bridges with constant depth box girders. In this technique, all segments required for one span are erected first and connected using post-tensioning to form a complete span. After one span is completed, the erection girder is moved to the next span, and the same process is repeated. Before final stressing, small adjustments are made using variable supports to achieve the correct alignment and level. This method is generally suitable for spans between 12 and 30 meters and provides rapid construction, with an average erection speed of approximately 3.5 days per span. Here we see the span-by-span method being utilized in the field to advance the deck structure. The progressive placement method is a one-directional bridge construction technique used for both cast in situ and precast segmental bridges. In this method, construction starts from one end of the bridge and progresses gradually towards the other end. As the bridge deck advances, temporary towers and stay cables provide support to the cantilever until the permanent structure is completed. This method is generally suitable for bridge spans ranging from 30 to 50 meters. It is especially useful where uninterrupted construction is possible from one direction. Proper planning, accurate alignment, and continuous monitoring are essential to ensure safety, stability, and quality throughout construction. Now let us discuss the merits and demerits of the progressive placement method. One important advantage is that the construction process is simpler to control than the balanced cantilever method. It also allows the easy construction of bridges with horizontal curves, making it suitable for curved alignments. The substructure design is comparatively simple, and the flow of structural forces is easier to understand than in the balanced cantilever and incremental launching methods. However, this method also has some limitations. Erecting the first span is difficult and requires careful planning. The construction process is relatively time-consuming and demands a large workforce, along with additional machinery and equipment. The incremental launching method is commonly used for bridge decks, having lengths greater than 250 meters. In this method, the bridge deck is constructed behind one abutment in a casting yard and then gradually pushed forward towards the piers using hydraulic jacks and sliding bearings. This technique is highly suitable for the rapid construction of long bridges because work can continue in a controlled environment. One major advantage is that temporary supports are not required, reducing construction difficulties over rivers, valleys, or busy roads. Using this method, bridge decks up to 1 kilometer in length can be constructed at an average rate of 30 meters per week. The construction sequence of the incremental launching method begins behind one abutment, where a highly mechanized prefabrication deck mold is installed. A rigid framework is then fixed to enable the casting of bridge deck segments using the cast in situ method. Each deck segment is generally 5 to 30 meters long. After a segment gains sufficient strength, it is placed on sliding bearings and gradually pushed forward into the span using hydraulic jacks. A steel launching nose is attached to the front of the first segment to reduce cantilever bending and safely guide the bridge deck as it approaches and crosses the first pier. This photo shows the Jules Verne Viaduct, demonstrating the scale and application of the incremental launching method for tall structures. The Movable Scaffolding System, MSS, is mainly classified into two types, underslung MSS and overhead MSS. In the underslung MSS, the main supporting girders are positioned below the bridge deck during construction. In the overhead MSS, the supporting girders are located above the bridge deck. The selection of either type depends on the bridge design, span length, site conditions, and construction requirements. The construction sequence of the Movable Scaffolding System, MSS, begins by fixing a pair of support brackets on 3 consecutive bridge piers. Launching wagons are then placed on these brackets to carry the scaffolding system. Next, the main girders and launching noses are installed on top of the launching wagons. Transverse beams are connected between the main girders to provide stability. After this, the external and internal formwork is fixed, followed by placing reinforcement and concreting. Once the concrete gains the required strength and the reinforcement is stressed, the MSS is lowered and launched forward to construct the next bridge span. This diagram details the various components of the movable scaffolding system. Key elements include the main girders, launching wagons, internal and external formwork, support brackets, and main cylinders, all coordinated to move and support the structure during construction. The Movable Scaffolding System, MSS, offers several advantages in bridge construction. It is mainly used for the cast in situ construction of full bridge spans, ensuring good quality and structural continuity. Since much of the work is mechanized, the requirement for manual labor is reduced, leading to lower labor costs. Another advantage is that the radius and slope of each span can be adjusted easily to suit the bridge alignment. The installation of reinforcement bars is also simple and convenient. However, MSS has some limitations. It requires special roller bearings and launching jacks, and the traveling gantry system is efficient only for bridge spans ranging from 30 to 60 meters. Let us summarize today's lecture. Large span structures provide wide column-free spaces and are widely used in modern infrastructure projects such as airports, stadiums, factories, and exhibition halls. We also studied several important bridge deck launching techniques, namely the balanced cantilever method, span-by-span method, progressive placement method, incremental launching method, and the movable scaffolding system. Each method has its own advantages and is selected based on span length, site conditions, equipment availability, construction speed, and project requirements. Understanding these techniques helps civil engineers plan safe, economical, and efficient bridge construction. Thank you for your attention.